'Tis the season to change your tires at Pep Boys. When it comes to holiday travel prep, your local Pep Boys has you covered. Buy 3 select tires and get the 4th one free, instantly. Pep Boys offers online booking, text alerts to track your service, and mobile payments to pay on the go to get you back on the road safely. Make an appointment at pepboys.com and don't miss out on these incredible deals. Offer valid through November 30th. Requires installation and additional fees. See store for details or visit pepboys.com to learn more.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime, Series 22, Episode 96, for broadcast on the 27th of December, 2019. Coming up on SpaceTime, how galaxies get their iconic spirals. Astronomers get their best ever pulsar maps and measurements. And the United States Space Force officially commissioned. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study claims galactic magnetic fields could be playing an important role in shaping those elegantly sweeping arms of spiral galaxies like the Milky Way. The question of how spiral arms are formed has long puzzled astronomers, sparking intense debate. The new findings, reported in the Astrophysical Journal, are based on observations of the spiral galaxy M77, also known as NGC 1068, located about 47 million light-years away in the constellation Cetus the Whale. Using SOFIA, the spectroscopic observatory for infrared astronomy, a specially modified Boeing 747 airliner equipped with a 2.5-meter infrared telescope, astronomers found that the magnetic field lines in this spiral galaxy are aligned with the galaxy's spiral arms. The findings suggest that magnetic fields may play an important role in shaping the evolution and structure of spiral galaxies. One of the study's authors, Enrico Lopez Rodriguez from NASA's Ames Research Center in California, says scientists already have a pretty good understanding of how gravity affects galactic structures, but are now just starting to learn the role magnetic fields play. SOFIA's infrared observations show that the magnetic fields along the spiral arms of M77 are streamlines that closely follow the circling arms. Galactic spiral arms are filled with dust and gas, molecular clouds of intense star formation called starburst, and lots of newborn stars. The magnetic field alignment with the star formation implies that the gravitational forces that created the galaxy spiral shape are also compressing the magnetic field. The alignment supports the leading hypothesis for how spiral arms are forced into their spiral shape, known as density wave theory. It states that dust, gas, and stars in the arms of spiral galaxies are not fixed in place like blades on a fan. Instead, the material moves along the arms as gravity compresses it, like items on a conveyor belt. The magnetic field alignment stretches right across the entire length of the massive spiral arms of M77, approximately 24,000 light-years across. It's the first time scientists have seen magnetic fields aligned at such large scales with current starbirth in the spiral arms. All this implies that the gravitational forces which create the galaxy's spiral shape are also compressing its magnetic field, supporting the density wave theory. Celestial magnetic fields are notoriously difficult to observe. SOFIA's telescope is designed for infrared astronomy observations in the stratosphere at altitudes of around 12 kilometers or 41,000 feet. The Flying Observatory's newest instrument, the High-Resolution Airborne Wideband Camera Plus, also known as the Hawk Plus, uses far-infrared light to observe celestial dust grains, which align perpendicular to the magnetic field lines. From these results, astronomers can infer the shape and direction of the otherwise invisible magnetic field. Far-infrared light provides key information about magnetic fields because the signal's not being contaminated by emissions from other mechanisms, such as scattered visible light or radiation from high-energy particles. Further observation should help astronomers better understand how magnetic fields influence the formation and evolution of other types of galaxies, such as those with irregular shapes. You're listening to SpaceTime. Still to come, the best ever map and measurements of a pulsar, the US Space Force officially commissioned. And later in the science report, how cats use marks on their ears to help them communicate. All that and more still to come on SpaceTime. Astrophysicists are literally rewriting and redrawing the textbooks on pulsars after obtaining the most precise and dependable measurements of both the pulsar's size and its mass, as well as the first ever map of hotspots on its surface. Pulsars are rapidly rotating neutron stars, the super-dense stellar cores of stars far more massive than the Sun, which have ended their lives in spectacular supernova explosions. The new observations were provided by NASA's Neutron Star Interior Composition Explorer, or NISA, an X-ray telescope mounted aboard the International Space Station. NISA has been studying a pulsar catalogued as J0030 plus 0451, which lies in an isolated region of space some 1,100 light-years away in the constellation Pisces the Fish. While studying the pulsar, NISA revealed that the shapes and locations of million-degree hotspots on the pulsar surface are much stranger than generally thought. One of the study's authors, Paul Hertz from NASA Astrophysics in Washington, says from its perch on the space station, NISA is revolutionizing science's understanding of pulsars. Pulsars were first discovered more than 50 years ago as the beacons of stars that have collapsed into dense cores, behaving unlike anything seen on Earth. NISA allows scientists to probe the nature of these dense remnants in ways that seemed impossible until now. A series of papers analysing NISA's observations of J0030 have appeared in a focus issue of the Astrophysical Journal Letters. When a massive star dies and runs out of fuel needed for nuclear fusion in its core, it ultimately collapses under its own mass and then explodes as a supernova. These stellar deaths can leave behind neutron stars which pack more mass than our Sun in a sphere just a dozen or so kilometres wide. Pulsars, which are one class of neutron star, can spin up to hundreds of times every second, sweeping beams of energy across the universe like a lighthouse beacon. And J0030 spins at some 205 times a second. For decades, scientists have been trying to figure out exactly how pulsars work. In the simplest model, a pulsar has a powerful magnetic field shaped very much like a household bar magnet. This field is so strong it rips particles from the pulsar surface, accelerating them out into space. Some particles follow the magnetic field and strike the opposite side, heating the surface and creating hotspots at the magnetic poles. The entire pulsar glows in X-rays, but the hotspots are much brighter. As the object spins, these hotspots sweep in and out of view just like the beams of a lighthouse, producing extremely regular variations in the object's X-ray brightness. But the new NISA studies of J0030 show pulsars aren't nearly so simple. Using the NISA observations, teams of scientists mapped the pulsar's hotspots using independent methods and converged on similar results for mass and size. One team from the University of Amsterdam determined the pulsar had around 1.3 times the mass of our Sun, with all that material packed down into an object just 25.4 kilometres wide. This is what makes pulsars the densest objects in the universe other than black holes. The other team from the University of Maryland found the pulsar has about 1.4 solar masses and is around 26 kilometres across. A pulsar is so dense, its gravity warps nearby space-time, the fabric of the universe as described by Einstein's general theory of relativity, in much the same way as a bowling ball on a trampoline will stretch the surface. Space-time is so distorted by this frame-dragging process that the light from the side of the pulsar facing away from us is bent and redirected towards our view. This makes the neutron star look much bigger than it really is. The effect also means that hotspots may never completely disappear as they rotate to the far side of the star. NISA can measure the arrival of each X-ray from a pulsar to better than 100 nanoseconds, a precision about 20 times greater than previously possible. This allows scientists to take advantage of this frame-dragging effect for the first time. NISA is looking towards the pulsar's northern hemisphere. Now, based on the textbook image of pulsars, when astronomers map the shapes and locations of the hotspots on this neutron star, they expected to find just the one. but instead they detected between 2 and 3 hotspots, all in the pulsar's southern hemisphere. Computer simulations by the University of Amsterdam, using overlapping circles of different sizes and temperatures to recreate the X-ray signals, identified 2 hotspots, one small and circular, the other long and crescent-shaped. However, computer simulations by the University of Maryland team with ovals of different sizes and temperatures instead found 2 possible and equally likely hotspot configurations. One has 2 ovals that closely match the pattern found by the University of Amsterdam team. The other adds a third cooler hotspot slightly askew of the pulsar's south rotational pole. Previous theoretical predictions suggested that the hotspot locations and shapes could vary, but these studies are the first to map these surface features. Scientists are still trying to determine exactly why the pulsar's hotspots are arranged and shaped the way they are. But for now at least it's clear that pulsar magnetic fields are far more complicated than the traditional 2-pole model. NICE's main scientific goal is to try and precisely determine the masses and sizes of several pulsars. With this information, scientists will be able to finally decipher the state of matter in the cores of neutron stars, matter which has been crushed by tremendous pressures and densities that simply cannot be replicated here on Earth. You're listening to SpaceTime. Coming up next, the United States Space Force is now a thing, and a third spacewalk for crews aboard the International Space Station as they carry out a service and upgrade to their Alpha Magnetic Spectrometer, a device designed to capture cosmic rays and antimatter particles and hunt for signs of mysterious dark matter. All that and much more still to come on our final episode of SpaceTime for 2019. US President Donald Trump has formally signed the 2020 National Defense Authorization Act, which officially establishes the United States Space Force as a new 6th branch of the American Armed Services. The official signing ceremony was held at Joint Base Andrews in Maryland.
This is a truly historic day for the American Armed Forces. In just a few minutes, I will proudly sign into law the largest ever investment in the United States military. In fact, I can say the largest ever by far. Today also marks another landmark achievement as we officially inaugurate the newest branch of our military. This is a very big and important moment. It's called the Space Force. For the first time since President Harry Truman created the Air Force over 70 years ago, think of that, we will create a brand new American military service. At such a momentous statement, 70 years ago, the Air Force. With my signature today, you will witness the birth of the Space Force, and that will be now officially the 6th branch of the United States Armed Forces. That is something really it's a big moment. That's a big moment, and we're all here for it. Space. There'll be a lot of things happening in space, because space is the world's newest warfighting domain. Amid grave threats to our national security, American superiority in space is absolutely vital. And we're leading, but we're not leading by enough, but very shortly we'll be leading by a lot. The Space Force will help us deter aggression and control the ultimate high ground. I particularly want to thank Vice President Mike Pence. He was so involved in this with me. This was a real, with the spirit, the love that I think we can say, Mike, that we both had for this project, because we realized how important it is to our military, to our future, to our defense. So important. And it's going to blend in magnificently with everything else that we have. So I want to thank Mike Pence. Mike, thank you very much. Great job. It was nearly half a century from Kitty Hawk to the creation of the Air Force, and now it's 50 years after Apollo 11 that we create the Space Force. With today's signing, I will proudly appoint General J. Raymond the first Chief of Space Operations, and he will become the very first member of the Space Force, and he will be on the Joint Chiefs. He will be on the Joint Chiefs, which are now expanding by one position. That's a very powerful position. So, General Raymond, congratulations, and thank you for everything you've done.
The new branch will be stood up over the next 18 months to provide freedom of operation for the United States in space and to provide prompt and sustained space operations. The Space Force's primary duties will include protecting the interests of United States assets in space and deterring aggression from other nations in space. Both Russia and China already have their own well-established space forces within their military hierarchies. The US Secretary for Defense, Mark Esper, says space has become important to the American way of life, its economy and national security, and so the United States must be prepared as a nation to protect itself from hostile actions. The United States Space Force joins the Navy, the Marines, the Army, the Air Force and the Coast Guard on America's front line of defense. The Space Force will be part of the Department of the Air Force in the same way the US Marine Corps is part of the Department of the Navy. Its initial components and personnel have been transferred from the former Air Force Space Command, which operated the 14th Air Force and the Space and Missile Systems Center. This gives the new branch an initial 16,000 personnel. You're listening to SpaceTime. Still to come, a third spacewalk to service and upgrade the Alpha Magnetic Spectrometer aboard the International Space Station, and later on the Science Report, SBS Television wins the Australian Skeptics 2019 Bent Spoon Award for the worst pseudoscientific piffle of the year. All that and much more coming up on SpaceTime. The crew aboard the International Space Station have carried out the third of 4 planned spacewalks to service and upgrade AMS-02, the Alpha Magnetic Spectrometer, a device designed to capture cosmic rays and antimatter particles and to hunt for signs of mysterious dark matter. The spectrometer was originally designed for a 3-year operational lifespan attached to the outside of the orbiting outpost. But it's provided scientists with so much valuable data on cosmic particles that the decision was made to extend its operational life. And that raises the difficult question of how you service and update a delicate piece of technology that was never designed to be serviced, especially not in space. Engineers and scientists eventually came up with a plan, and the green light was given. After 2 successful spacewalks in November to access and disconnect 4 existing worn-out cooling systems, this third 6-hour, 2-minute EVA or extravehicular activity, that's NASA speak for spacewalk, focused on reconnecting pipes to the new pumping system. This orbital plumbing job was by far the most crucial of the 4 spacewalks. Astronauts began by passing the cooling system to each other as they slowly inched their way from the airlock to the space station's robotic arm. They then used the arm, which was being operated by astronaut Jessica Meyer from inside the station, to transport the equipment to the hard-to-reach worksite. Next, they attached the new pump onto the AMS, and then the system was powered on while all 8 cooling pipes were being reconnected. A 4th and final spacewalk to wrap up the servicing mission on the AMS is planned for a yet-to-be-confirmed date. India has launched a new spy satellite into orbit. The RISAT-2BR-1 was flown aboard an Indian Space Research Organisation Polar Satellite Launch Vehicle from the Satish Dhawan Space Centre on the Bay of Bengal coast. The PSLV rocket was flown in its QL configuration with 4 strap-on XL solid rocket boosters. It's only the second time a PSLV has flown in this configuration. The mission's primary payload was the 628-kilogram RISAT-2BR-1 reconnaissance satellite. It's equipped with a high-resolution synthetic aperture X-band radar capable of imaging targets day or night and in all weather conditions. The spacecraft, which is carrying enough fuel for a 5-year mission, was injected into a 576-kilometre high, 37-degree inclination orbit 16 minutes and 23 seconds after liftoff. Also on board for the ride to orbit were 9 small commercial satellites, launched under the Indian Space Research Organisation's new commercial arm, New Space India Limited. These included spacecraft for Israel, the United States, Italy and Japan. SpaceX has successfully launched the new JCSat-18 K-Cific-1 telecommunications satellite aboard a Falcon 9 rocket. The mission flew off Space Launch Complex 40 at the Cape Canaveral Air Force Station in Florida, the Falcon 9 core stage later returning safely to the Earth, landing on the drone ship Of Course I Still Love You, which had been pre-positioned downrange in the North Atlantic Ocean.
These two LOX loaders closed out, and vehicles on internal power. Falcon 9 is in startup.
Go for launch.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Liftoff.
Vehicle is pitching downrange.
Liftoff of Falcon 9, carrying the JCSat-18 Pacific 1 satellite to geostationary transfer orbit. Stage 1 is now in full power. Everything looks nominal. We're now, you heard the call out for throttling
Falcon
down.
9 is supersonic.
We're approaching max Q. This is when the rocket goes through the moment of greatest aerodynamic pressure.
Falcon 9 is experiencing maximum aerodynamic pressure.
Now, the next three events that we have coming up will be in rapid succession. Main engine cutoff, stage separation, and second engine start 1. Main engine cutoff, or as you'll hear it called out, MECO, is where all 9 engines of Falcon 9 first stage shut down. You just heard the call out for MVAC engine chill. Again, that's when we're pre-chilling those turbopumps on the second stage. Now, the MECO will be followed by stage separation, or the separation of the first and second stages. Finally, second engine start, where we'll light the Merlin vacuum engine on the second stage and begin to carry the satellite to its targeted orbit. So trajectory is looking good. Engine still at full power.
MECO. Stage separation.
There we go. We have confirmation
First
there
and second stage are on a nominal trajectory.
Of the stage separation and second engine start 1. Stage 1, as it begins its descent to the drone ship, Of Course I Still Love You. So we're coming up to fairing deployment. We jettison the fairing to shed any unnecessary weight from the second stage.
Fairing separation is confirmed.
Fairing has separated. Again, we are attempting to catch those on our recovery vessels, but we now have confirmation that second stage is performing nominally, and we are looking good so far for today's mission.
Acquisition of signal Bermuda.
Now, at this point in the mission, the first stage is currently on a parabolic trajectory from the launch site going towards Of Course I Still Love You, which again is about 350 nautical miles off the Florida coast. To successfully land, the first stage will need to do a few things. First, it'll need to reorient so its engines and heat shield enter the Earth's atmosphere first. Then it'll reignite 3 of its Merlin engines for entry burn to reduce the aerodynamic forces and heating experienced as it transitions back into the thicker parts of the Earth's atmosphere. Once it's in the atmosphere, the grid fins will take over, guiding the rocket towards Of Course I Still Love You. When we're above the drone ship, a little after T+8 minutes into flight, the center Merlin engine will ignite for landing burn, followed by landing leg deploy, and hopefully a gentle touchdown on Of Course I Still Love You. Entry burn is scheduled to begin in about a minute from now, and it'll last about 20 seconds.
First and second stage continue to follow a nominal trajectory.
The second stage MVAC engine continuing its burn.
Stage 1 FTS has safed.
Stage 1 entry burn startup.
And there's relight of those 3 Merlin vacuum engines. Now, fun fact, JCSat-14 was actually the first time SpaceX successfully landed a geosynchronous transfer mission on a drone ship. Since then, we've made 43 successful landings between drone ships and on land.
Stage 1 entry burn shutdown.
And we're hoping to make tonight's attempt our 47th successful first stage recovery. The second stage is continuing its first engine burn towards a parking orbit. That's taking the JCSat-18 Pacific 1 satellite up into orbit around the Earth to prepare for a second burn happening shortly after. Now, landing burn on the first stage and secondary engine cutoff number 1 will happen about the same time. Both of those are scheduled for about T+8 minutes.
Stage 1 entry transonic.
Second stage has entered terminal guidance.
At this point in the mission, the grid fins are guiding the first stage towards Of Course I Still Love You.
Stage 1 landing burn startup.
Stage 2 FTS is saved.
Seagull 1.
Stage 1 landing leg deploy.
Hearing cheers. Waiting for confirmation. Now, a bunch of things happen there. Secondary engine cutoff number 1 just happened. The spacecraft is in a good parking orbit, and booster 1056 has just recovered it for the 3rd time. This is our 47th successful landing. Congratulations to the whole team here. Now, with that, the second stage is currently in orbit and will continue coasting for about 20 minutes until the phasing is correct for secondary engine start number 2.
The same Falcon 9 core stage had previously flown on both the CRS-17 and CRS-18 Dragon cargo ship missions to the International Space Station back in May and July. SpaceX also attempted to capture the Falcon 9's payload fairings using two chaser boats, Ms. Tree and Ms. Chief, but failed on this attempt with both sections splashing down in the ocean. Still, the Hawthorne, California-based company did retrieve them later and will attempt to refurbish them for reuse on future missions. The JCSat-18 Pacific-1 satellite is a high-throughput communications satellite jointly owned by Japan's Sky Perfect JSAT and Singapore-based Pacific broadband satellites. The spacecraft's Pacific-1 payload is designed to deliver broadband services using 56 Ka-band narrow beams selectively tailored to cover precise pockets of demand in a geographically dispersed footprint of 20 Pacific and Southeast Asian nations. Meanwhile, the JCSat-18 payload aboard the spacecraft uses conventional Ku-band transponders and spot beams, providing mobile and broadband services across the Asia-Pacific, including Far East Russia. It may be the end of the holiday season, but China's space blitz of late is continuing with the launch of two more Bedao 3 navigation satellites, followed by a new Sino-Brazilian Earth observation satellite. The Bedao 3 MEO 23 and 24 navigation satellites were flown into orbit aboard a Long March 3B rocket from the Zhaichang Satellite Launch Center in southwestern China's Sichuan province. The spacecraft are the 43rd and 44th in the Bedao navigation satellite system, the 17th and 18th of the new Bedao 3 navigation satellites, and the 23rd and 24th Bedao satellites placed into medium Earth orbit, marking the completion of the core Bedao 3 constellation system. However, China plans to launch another 8 Bedao 3 satellites next year as orbital spares. 3 into medium Earth orbits, 3 into inclined geosynchronous orbits, and 2 into geostationary orbits. Meanwhile, just days after the Bedao 3 launch, Beijing launched a Long March 4B rocket from its Taiyuan Satellite Launch Center in northern China's Jiangxi province, carrying a new joint Chinese-Brazilian Earth resources satellite, the CBERS 4A. The new probe will replace the existing CBERS 4 satellite, which was launched back in 2014. The new spacecraft's equipped with 3 optical payloads, a Chinese-built wide-range panchromatic multispectral camera, a Brazilian-built multispectral camera, and a Brazilian-built wide-field imager. The probe will collect remote sensing data, surveying land resources and environmental conditions, and undertaking research into climate change. The mission also carried 8 small microsatellites into orbit, including Ethiopia's first-ever spacecraft, the ETRIS-1, a wide-range multispectral remote sensing satellite. Russian Space Forces have launched the Soyuz 21B rocket carrying a GLONASS-M navigation satellite into orbit. The Soyuz, equipped with a frigate upper stage, was launched from the Plesetsk Cosmodrome 800 kilometers north of Moscow. The spacecraft was successfully deployed into a 19,100 kilometer high orbit where it'll replace an older satellite. GLONASS is a Russian satellite navigation system similar to America's GPS, China's Bedao, and Europe's Galileo global satellite navigation systems. The GLONASS constellation consists of 24 satellites spread over 3 orbital planes with 8 satellites in each. Designed for a 7-year lifespan, the GLONASS-M is a 1,415 kilogram second-generation navigation satellite. It's not known how many more GLONASS-M satellites are likely to be launched, as Moscow's already started flying the newer, more advanced third-generation GLONASS-K1 and is expected to begin flights of the even more advanced K2 shortly. And time now to take another brief look at some of the other stories making news in science this week with a science report. Well, the bad news is it is now impossible for Earth not to increase average global temperatures by 2 degrees Celsius in coming years. To make matters worse, a new study warns that depending on how quickly that increase occurs, we could see local temperatures get even warmer. A report in the journal Nature Climate Change looked at the climatic impacts of global warming to the same temperature either quickly under high emission scenarios or over a longer period of time. Scientists found that for the same global temperature increase, between 85 and 91% of people worldwide would experience higher average local temperatures with short-term warming compared to a longer-term, more stable warming regime. The likelihood of extreme heat is also at least twice as high in some places under the short-term warming scenario. And for Australia, it's also projected to be hotter under the rapid warming scenario compared to the slower warming equivalent. A new study published by the CSIRO's Centre for Southern Hemisphere Ocean Research warns that global warming will make it more difficult to predict year-to-year global climate variations. The findings, reported in the journal Nature Climate Change, are a consequence of changes to long-term climatic patterns in the Northern Hemisphere. The results point to the culprit being the effects of global warming on the Pacific Decadal Oscillation, a year-round pattern operating across the Pacific Ocean. In a time of global climate uncertainty and growing populations, reliance on alternative sources of clean drinking water is ever increasing. New research led by Southern Cross University has found an unexpected benefit at the Sydney desalination plant. It seems the excess salty water discharge is attracting lots of fish. The desal plant's been activated following the record-breaking drought, which is drying the entire Australian continent and showing no real signs of easing. You can read the findings in full in the Journal of Environmental Science and Technology. A new study has found that eating more ultra-highly processed foods, such as cakes, ready meals, sweetened breakfast cereals, burgers and hot dogs, has been linked to an increased risk of developing type 2 diabetes. The findings, reported in the Journal of the American Medical Association, looked at more than 100,000 people. Researchers found that those with a higher proportion of ultra-processed foods in their diet were also at a higher risk of type 2 diabetes. Melanism, the darkening of the skin or body tissue, is thought to help cats camouflage at night, regulate their body temperature, and even resist parasites. But a report in the journal PLOS ONE suggests this can also create a dilemma for when cats, especially wild ones, need to communicate in the dark. Scientists found that cats with white markings on the backs of their ears could visually communicate better at night, while at the same time not being spotted by predators or prey. This suggests that white marks on the ears of cats originally evolved as a way to help the nocturnal predators hunt in their forest homes. SBS Television has taken out the Australian Skeptics 2019 Bent Spoon Award for the worst pseudo-scientific piffle of the year for their absolutely appalling series Medicine or Myth. SBS won the award for comprehensively misinforming the public as to exactly how safe and effective various products and therapies really were, providing conclusions that had little to do with science. Tim Mendham from Australian Skeptics says SBS beat out an infamous pack of nominations this year, including several from the ABC, as well as a number from universities and retail chains.
There was a lot of nominations. Of course, ABC, Landline was nominated, 60 Minutes was nominated, Newcastle University.
ABC, dear oh dear.
I know, the great ABC. Well, Landline program was nominated there, so never mind. Newcastle University, even the Prime Minister was nominated. The National Seniors Lobby Group was nominated for promoting sort of weird supplements. But the winner, drumroll, was SBS TV for its program Medicine or Myth, which basically had a panel of 3 medical people who were assessing alternative medicine proposals, a lot of them home cures and that sort of thing, to see if they had any potential or effectiveness.
When you think about something like that, a lot of very legitimate medicine is based on home cures, so they can work, but I guess it depends on how much scientific evidence there is to support them.
Yeah, I mean, a lot of the home cures are sort of like the starting point, the medical treatment, in the same way as sort of products that come out of the rainforest or whatever, right?
Yeah.
It's
have
the starting
some willow
point,
bark and you'll get rid of your headache. And these days we call
have some. Yeah, it then comes down to refinement and to seeing, scientific testing, as you say, to seeing if there's something there. And often there's something there, if there is anything, is buried amongst a lot of other stuff that doesn't work or just messes up all the potential sort of investigations. But if you can refine it down to something that works, it becomes more effective, and that's fine. Just that some of these things has been tested that were being promoted on this program, and they have found to have nothing. One of the particular ones that was pointed out was something called emotional freedom techniques, which has also been described as psychological acupuncture. You basically just tap with a couple of your fingers down along your body on the meridians, which also don't exist, to try and relieve stress and that sort of stuff. Well, maybe tapping on your table relieves stress is also a sign of stress. And the judges took that one seriously to the extent that they sent it out for some trials to see if it works. They're pretty ordinary trials, you could say. Not a lot of people involved and not extremely scientific.
Proper double-blind testing, I assume?
No, yeah.
No?
No. But the problem is, of course, that even giving it some sort of imprimatur like that to say it's worth testing gives it a lot of publicity on national TV. Now, there were some things there that were obviously sort of just totally jokey, and the judges looked askance, but they looked at enough things, which they should look askance at, that they seemed to take seriously, certainly more than one of them, of the 3 judges, and that was our worry, that it's the people watching don't necessarily see the tests, they don't see all the context of it, they just see 3 judges even listening to some of this stuff means it's worthwhile following.
And who
honestly,
were the judges?
Judges were, one of them was a well-known neurosurgeon who has been around a lot. He's obviously not shy in self-promoting. Another one was a GP and author, and a third one was a biochemist, immunologist, associate professor.
Good credentials there.
Yeah, you've got quite worthwhile credentials, and that is part of the problem, of course. That if people with these credentials are giving these things credence, then you have to wait. Yeah, if the judges were all sort of out and out New Age hippies and things, you'd say, oh yeah, they're giving the awards to their friends, or giving, sort of following up for tests because of they have the same point of view. These judges should be dispassionate about it, and maybe they were. You never know, of course, with TV programs how much editing goes on and how many raised eyebrows there might have been. But even so, having some of this stuff on TV is a great worry. So everyone agreed that medicinal myth or hidden myth was actually a well-deserving winner of the Ben Spoon.
And of course, Australian taxpayers are helping to pay for programs like that, so we can all be proud.
That's right. My money goes there. Your money goes there. I really would rather spend on something real and science and medicine rather than this myth stuff.
That's Tim Mindham from Australian Skeptics. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcasts, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audioboom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web that I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram. On Facebook, just go to www.facebook.com/SpaceTimeWithStuartGary, and you can also find us on the SpaceTime with Stuart Gary YouTube channel. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.